You can do it, Lee.
STEM engineering, it's changing as we speak. A lot of things are on wheels, and we designed it that way because we anticipate that we're going to be evolving as we go along.
Some days it doesn't really feel as much like a class. Some days I feel like I'm in robotics, where I'm like kind of here after school, like a club type thing.
Then we send it up the floor too and let it come back down on its own.
When I was very young, I always had an interest for kind of like building, inventing type things. And of course, when you're younger, you don't just put together like, oh, I want to be an engineer. So you don't really know what it's called yet. And so when I came to school here and they had the STEM classes, I decided to just take advantage of that and see kind of where it'd take me.
It's been phenomenal. I mean, we started off, we were very cautious. We handpicked some kids to do the first class, and we had only 10 kids work the program. It was an introduction to engineering design. The following year, we had 75 kids involved with the classes now. And they're telling me now I got people asking for it left and right. There you go. I've talked to professors from UT Chattanooga, CBU, University of Memphis, and it's interesting, they have jobs, they have more jobs than they have students for kids that are coming out. In other words, the kids are actually have a choice of stuff they can go into. And there's people recruiting to get signing bonuses.
I know I want to major in mechanical engineering. I've thought about wanting to work for the military.
STEM programs all around the country are using the Project Lead the Way, so we think it's one of the strongest ones. It's one that's most integrated into high school.
There you go.
We've had some kids from the PLUS program excel in our STEM program because it is an alternative way of learning. It is a hands-on approach learning, and some kids really just adapt well to it and do very well at it.
I also like the hands-on aspect in this class on like how you don't just think of a concept and then look at it on a board or think of it on a computer, but rather you actually build it in real life and you actually test what you can do to make it actually work in real life, not just on a screen.
Like different aspects of physics, that's a lot of what we've been doing right now, and like how to use different types of technology and coding. I didn't know a lot about coding before this year, and now I definitely know a lot more. You program each part up this electronics board that you have to put together. And so you go through and code each thing. So it's like it's teaching you how to code different things, and sometimes we got to like play around with it and do our own little things. So I thought that was really cool.
We have done a project about architecture with bridge building.
We had to design our bridge and put in all our information about it, like all our paperwork, and turn it in. It was very cool.
We almost become an art class, and in fact, we learn how to draw these things. We learn how to sketch out ideas and work on things, and then we move from those sketching and understanding objects to actually working with an AutoCAD system. We have some very strong computers here in the lab that can run an Autodesk Inventor program, which is basically an AutoCAD, where they can design things right from scratch. They go from 2D sketches to turning them into 3D objects, and then they can turn around and apply textures to them. They can add to the intricacies of the object. And we've got some kids that just really take off on it. We can print out some of the objects. If they design something, we can actually bring it right to life on our 3D printer, and they can look at it and hold it in their hand at the end of the day. So that's fun too.